Okay, we are going through the geometric design of the road. So we have discussed the horizontal curve, and now we are discussing the superelevation. Okay, so superelevation has two parts. One is this one, the other one is this. Okay, this one, the length for this one is called LT, and the length for this whole thing is called LR. Okay, so we calculated both of them in one of the examples. Okay, and then later on you can add it and you can know total length required for the superelevation. Okay, and then we divide it in the tangent and the curve. Okay, the division can be 2/3, 1/3, 2/3 on the tangent, 1/3 on the curve, or it can be 80-20. 80 on the tangent, 20 on the curve. In some special cases, before the curve, we can provide a spiral curve.
A ghost.
All of us are ghosts. So, before the curve, you may provide a spiral transition curve, which is a higher degree curve. Why higher degree? Because this curve does not have a constant radius. It has a changing radius. In which situation we provide a spiral transition curve when the degree of the curve is more than 3. Okay, when the degree of the curve is more than 3, then we can consider providing a spiral transition curve. If we provide a spiral transition curve, then we will have the following advantages. First of all, when we go on the curve, the cross section of the road needs to be changed. Okay, you need to provide superelevation. Okay, so this is a change in slope. Okay, and we also need to change the width of the road for the trucks. Okay, to make the curve, they need bigger or larger lane widths. Okay, so this change can be done on the spiral transition. Okay, this change can be done on the spiral transition curve. And one more thing is, it can spiral transition curve will enhance the appearance of the highway. Okay. When drivers are on the highway, sometimes because of the appearance, they may feel uncomfortable. It may look to them that the highway is very steep, the curve is very sharp. And they may try to change the lane, they may try to brake suddenly and so on. So this can create a problem. A spiral curve will solve this problem. Okay, it will make the highway look more gradual, more smooth. Okay, so a spiral curve has these advantages. For the spiral curve, these are the calculations we can do. Starts first of all, look at the geometry of the curve. We have a spiral curve, a circular curve, a second spiral curve. Tangent, spiral, circular, spiral, tangent. Okay. First point of spiral. First point of first spiral. Tangent to spiral. Last point of first spiral. Spiral to curve. Circular. Yes. First point of second spiral. Circular to spiral. Last point of last spiral. Spiral to tangent. Pi, intersection point. Delta, deflection angle. Okay. Delta S, angle of circular curve only. Okay. Angle of spiral curve, this delta. Okay. Delta S, circular curve. This delta, spiral curve. Okay. TS, tangent length with the spiral. Tangent length with the spiral. Okay. Now, first of all, we have the equations for length of the spiral. Maximum length of a spiral, minimum length of a spiral. Maximum length, one equation, one value. Minimum length, two values. Okay? You will have two values, both of them will be different because they are coming from different equations. So we will pick which one? The higher. Okay? Why the higher one? Because the higher one will satisfy both of them. Okay? So this one is 100, this one is 200. If you pick 100, then 200 is not satisfied. Okay, but if you pick 200, 100 is also minimum, right? Yes. So we satisfy both of them. Okay. So maximum, minimum, okay. In all of them you can see we are using R, right? Yes. Okay. Now this is radius of what? A spiral curve or circular curve? Which one has a radius? A spiral or circular? Circular. Circular has a radius. Okay. So radius of circular curve. S means speed of the road. Okay. Angle of the spiral curve. Length. Okay, so you have to pick a length now. This will give you a range. This will not give you a value. It will give you a range. Okay, and you have to pick a value. So the value you picked, degree of the curve. This will give you the angle of spiral. Then we have angle of circular. So total angle minus first spiral, second spiral. Two spirals, right? Okay. So total angle minus first spiral, second spiral. Remaining is
the center.
okay. Angle of circle. Then we have tangent of this one.
The lines.
Okay. The tangent of this one. Clear? Okay. The previous equations will give us a range of the length of the spiral curve, minimum and maximum. Okay, but we still have to pick a value, right?
Yes.
There are some suggestions. Which value should we pick? There are some suggestions. Okay, but any value in the range is fine, and any value out of the range is not allowed. Any value in the range is fine, out of the range not allowed. If you pick a random value from the range, allowed. Random. Okay, so the range is between 100 and 300.
Take 150.
Huh?
150.
150 allowed. Just took it from without any calculation, without looking at anything else. It's fine, allowed. Okay. But from here, you pick a value 50, but your range was 100 and 300, not allowed. Okay. So these suggestions cannot go against the range. Got it? Okay. What are the suggestions? First of all, this is a divine table. Okay, a God-given table.
So
Yes, because we don't know from where it came.
from the Bible or
Huh?
Bible.
It's from Allah. Allah can give from anywhere, right? Okay, we don't know from where. Seriously, I don't know from where. Okay, but we have this table. That's why I'm saying it's a God-given table. Okay, so you can pick a value according to your design speed from the table. Another option is you have the total length of super elevation. Pick that as spiral curve, length of spiral. Okay, total length of super elevation can be equal to length of spiral. Another option is not the total length of the super elevation, just the end part. Just the end part. This can be length of the spiral. Okay, so we have three options. Option number 1, option number 2, total super elevation length. Option number 3, the last part of super elevation length, which we call as LR, super elevation runoff. Okay, so we have three of these options, but any of these options cannot be out of the range. Okay, if they are, that cannot be taken. Okay, you have a 4-degree curve and 12 feet lanes. We have 2 lanes. The speed is given, maximum super elevation is given. The speed is given. For this speed, the friction factor is this much. We have a table for that. Okay, normal slope of the road 1%, 0.0. They are saying we will provide this with a spiral curve. So give us the points of the spiral curve. The start point, the end point, and so on. The point of intersection is given. The deflection angle is given. Clear?
Yeah.
Okay. The first thing we will do is the degree of the curve is given. Using the degree of the curve, I will calculate the radius. Okay, how much is the radius? 1.43 point 4. Okay. Now the radius has another equation, which is this one. Okay, now look at this equation, look at the data and the question. Do we have anything unknown in this equation?
Super elevation.
The elevation is unknown.
No, given.
Is given?
Oh, unknown.
Unknown.
It's not written enough. Super elevation.
So what is this? And
Oh,
third
okay,
line.
okay. Left chain. Factor. Back
Given.
Yeah.
Everything is known, right? Okay. But the super elevation which is given is maximum, not actual. So they are telling us that super elevation could be this much or less. How much is it? I don't know.
So you can take it.
What?
You can take it.
No, no.
It's maximum.
Because I already have an equation for R. And I already know R.
Okay.
So I will now calculate E.
Okay.
Super elevation. How much is super elevation now? Tell me.
اللي مجهولة يعني شو بتحسب؟
0.047.
Okay, so the maximum is 0.06. Your actual is 0.047. Okay? Is it good? Okay? It's less than the maximum, which is fine. If it was 7%, then I will take the maximum and recalculate the radius. Okay? Then the radius is not acceptable then. Clear? Okay. Now they are asking me to do the calculation for the spiral curve, right? Okay, so I will start with the calculation of length of the spiral curve. For length we have three equations, two for minimum, one for maximum. Give me the minimum and maximum spiral curve. You need radius and speed. Speed is 60, radius is given here.
For maximum 336.8.
336.8. Yes, minimum. We have two values.
150.6.
150.6 and 1 point 0.785 into S cube. 80.
118.7.
Okay, so we have two minimum, right? 150.6 and 118.7. Which one will I take as minimum? The higher one, 150. Okay, so I will take 150. So my range is 336 to 150. 336 to 150. Can I pick a value 200?
Yeah, but
200?
it's
300?
No.
No?
Temporary max. Yeah, okay.
Okay, 350?
50, no.
No. Okay. Now, which one will I take? First of all, I look at my table. My speed is 60, so my length can be 176. This is one option. Okay. One of the options is to make the length equal to 176. Okay. The other option is the length can be equal to LR only, or it can be equal to LR plus LT from super elevation. Okay. So I will see what is my LR now. Okay. This is the equation for LR. Okay, W is the width of the lane. It is given as 12 feet. Okay, my lanes are 12 feet. N1 is the number of lanes rotated. Okay, N1 is the number of lanes rotated. I have total 2 lanes. Okay, I'm just reading the values from the question. Okay, I have total 2 lanes. When you have 2 lanes, we take the lanes on one side of the reference. My reference is center. Okay, so if you have 2 lanes, one side of the center means 1 lane. Okay, so my N1 will be 1. Clear? Okay, so N1 is 1. Okay, my next thing I need is my super elevation. Super elevation we calculated 0.04. The actual one, not the maximum. Okay, then I need BW. BW has fixed values. You can see here. Okay, BW has these values. So for one lane, BW is 1. Okay, the BW is 1. Then I need delta. Delta comes from this table. Okay, for a speed of 60, delta is 0.0045. Okay, so how much is LR? This one. $120. Now, is this a possible option for the length? Yeah.
How long
Now, what do you say? Can I take it as the length of the spiral?
Yeah. Within the range.
Where's the range? What's the range?
Can you show me the الصورة?
Okay.
From the range of
the spiral.
Spiral.
Okay. So it's not in the range. So LR cannot be taken as the length of the spiral. Okay. This option is gone. Okay. Now the third option was that I can make it equal to the total length of the super elevation. Total length means LR plus LT. LR I already have. This is the equation for LT. Okay. My normal slope is 1%. So how much is my LT? LR you already have, super elevation you already have. Okay, how much is my LT? Sorry? 26.7. Okay, and what will be total? LR plus LT? 1, 5, 2. Can this be my length of a spiral? Can this be the length of the spiral? It can be, right? My range is between 150 and 330. Okay, so this is one possible value. Okay, so 152 can be the length, or 176 from the table. Both of them are possible. The third one, LR, is not possible. It's out of the range. Okay, so for the sake of this question, we will take 152. Okay, we will take 152 as the length. The final length of the spiral is 150. Okay. Now I have to calculate the stations of these points. Okay, these points. I'll start from here. Okay. This station is given in the question. Okay. I can calculate this one if I know TS, the tangent length. Okay. Tangent length has this equation. Okay. R I already know. Okay. Delta is the deflection angle which is given in the question. That is 38 degrees. Okay. It's given in the question, 38 degrees. Okay. What else do I need? I need the small delta, this one. Okay. This is the angle of the spiral. So you can see the equation over here. Okay, d is the degree of the curve, 4, the one which we use for calculating radius. Okay, so d is 4, LSP is 152 feet. Okay, so how much is this small delta?
How much D is that?
4, the one which you took for radius. Degree of the curve. How much? 3.0. 04. Okay, so small delta we have, LSP we have. Okay, so give me TS. How much is the tangent length?
We take half the distance, because of T until the point of
Intersection. Point of intersection. The station is given from the point of intersection.
Okay. So, and we have the length. We have half the length.
No.
You want the point, no?
I have this station.
Okay.
I want this one. So I'm calculating this.
Okay, okay. And the one.
Yes, how much?
So subtract.
Okay, so now to calculate the first point, which is TS, tangent to spiral, I'll take the station of PI, which is given in the question, 11 plus 62 minus this length. How much is that? Point? 37? 27 point? 0.4. 0.5? 0.6? Okay. Next point from here, next point is the end of the first spiral. So between them is the length of the spiral, right? How much is the length of the spiral? Okay, so we add it. Sorry?
Yeah.
Yes, how much is this? $39.6. Okay. Now the next point, 29.
49? 14, sorry.
Okay. We are at this point. From here to here, we have the length of the circular curve. This is a circular curve. Okay. I need to calculate the length of the circular curve. The length of circular curve is okay. This is the length of the circular curve. Okay. My D is 4 degree of curvature, 4 delta. Now delta, I have to use delta of the circular curve. Okay. This is total deflection angle. This is total deflection angle. My circular curve is not total. My circular curve is only a part. So I have to take the angle of this part only. Okay. Where is the angle of this part? It is here. Okay. So total was 38. From 38, you will subtract 2 times the delta S. Del S, the small delta. So 38 minus 2, 3.04. Mm-hmm. 31.92. Okay, so I will use this one in the length equations. How much is the length? Hmm? 12? Let me check. D4, yes. Let me check the equation. 100, no, the other way around. 30 will go on the top, 4 at the bottom. So it's del upon D. So 100 into 31.92 divided by 4. How much? Point? Yes. Okay. So I have SC now, which is the beginning of the circular curve. I want the end, I will add the length. Okay. So 7 plus 49.6 plus the length of the circular curve 798. How much is it? So this will be my circular to spiral. How much? What? 800. 749.6 plus 798. What 40? 749.
749.6.
798. How much? How much? 1,500. Okay. So this is now the start of the second spiral, end of the circular, start of the second spiral. Okay. Then we need the end of the spiral. This is the start. We need the end. I will add the length of the spiral.
Station last I have plus 4.
Yes. Yeah, how much was the last one?
That's I still have been handled. I'm sorry, I saw it's happened as well.
One six. Okay. Now let me recap what we did. Degree of the curve was given. Using degree of the curve, I calculated the radius. Using the radius, I calculated what is my super elevation, and this should be under the maximum value. Okay. Then using the speed, okay, and the radius, I calculated the range of a spiral curve. Okay. Then I check this range against the value which is given in the table, and LR and LR plus LT. Value in the table was fine. LR is less than the range, I cannot take it. LR plus LT is also fine. So I took LR plus LT as my length. Then I started calculating the parameters of the spiral curve. I started with the tangent length. Pi minus tangent length gives you the starting of the spiral. The start of spiral plus the length of spiral, end of spiral.
So
Then
we subtract them.
End of first spiral plus length of circular curve. The start of second spiral. The start of second spiral plus length of spiral, end of second spiral. Okay. So this is how we calculated it. Any questions?
No. But so I think it was more easier in highway course.
Yes.
Just cosine theta. Now too many equations. Easy, inshallah. If you bring it in,
Inshallah.
God knows.
Okay. Now, we have been discussing side distance whenever we are designing the road. The most important thing about the road is the side distance. Why? Because of the point of view of safety.
This is steep.
When we design the curves, side distance could become a problem. Why? Because of the curvature of the road. Okay, you can see here, this is my road and it is going around like this. So I cannot see the other side. I cannot see the other side because of these trees. Okay, so the roadside object can block your view. Okay, so we have to make sure that we have enough side distance on the curve. Okay, how do we do that? We assume first of all that the side distance I need on the curve is equal to s. Okay, s is the side distance I need on the curve. Okay, it could be stopping, it could be passing, it could be decision, whatever we discussed earlier. Okay, there are different types of side distance. So you have to select s is which one according to the road condition. Okay, this is my object which can block my view. Okay, this is on the side of the road. So I want to see from here to here, my full side distance, right? And this is my object. The distance from the, now if this is the curve, then what do we call this line?
Tangent.
No, this is tangent. What do we call this one?
How did you say it?
Yes,
I remember it.
chord.
Chord.
Okay. So the distance between the curve and the chord. Now what is my curve? The road. What is where is the chord at the object? Okay. So the distance between the curve and the chord is represented with m. Okay, m means the distance between the curve and the chord. In this scenario, m has a special name. which is called horizontal sightline offset. Okay. So when you are discussing sight distance along the curve, then M becomes horizontal sightline offset, which is the distance from the road to the object. Alright? So M is general. Any distance between the curve and the chord is called M. Okay? But when you are discussing sight distance, then M is called horizontal sightline offset. Okay? So you have to make sure M is enough for the sight distance. How do you do that? We have two equations which we already know from the geometry of the circular curve. Okay? First equation is for M. Distance between the curve and the chord. Distance between the road and the object. Okay? In this equation we have R, radius. We have delta, which is the deflection angle. Okay? We have another equation which is for the length of the curve. We used in the last equation, last question, right? Length of the curve equals to 100 into delta upon d. Delta is deflection angle, d is degree of the curve. Okay? Now if I look at this picture, my length is equal to sight distance, right?
Yes.
My length equals to sight distance. So equation of length equals to sight distance. Okay? Now this equation you have delta, right? So I derive this equation for delta. Then I take this equation and replace it here in the equation of M.
By radian, yeah, Victor?
Huh?
By radian we make
No, it's degrees. All of it in degrees. Okay? So this is my equation of M. Okay? Now in this equation you can see we have degree of the curve and we have the sight distance. Okay? Degree of the curve and radius have this equation between them. Radius equals to this. Okay? So wherever I see radius, I can replace it with this. Or wherever I see d, I can replace it with this upon r. Okay? So we don't need to keep r and d both. We can keep one of them. Okay? So if you replace r with this, your final equation is this one. There is no r, only degree of the curve. Okay? If you want to replace d and keep all the r's, then your final equation is this one. So you only see r. Okay? Clear? Okay? So now, as I mentioned, sight distance can be of different types: stopping, passing, intersection, decision, whatever. Okay? 95% of the cases, my sight distance is for stopping. Stopping is a normal standard. Okay? Normal standard for providing sight distance. Okay? So in most of the cases, we will be using this equation of sight distance, which is for stopping. Clear? Okay. So we have this question. Okay, 6-degree curve measured from the inside lane. Okay. Now see, this is my road. It can have more than one lane, right?
Side lane means.
Okay. Inside lane means the closest one. Okay. So we always check this for the closest one. The worst case. If it is fine for the closest one, the other one is also fine. It has more distance, right?
Yeah.
Okay. So if the minimum is enough, then the others are more. Clear? Okay. So 6-degree curve, speed of 70, and the per section reaction time 2.5 seconds. Okay. They want to find out how much an object should be from the road on the curve. Yes, not like this. Okay. So first of all, I will calculate my sight distance. Okay. My speed is 70. My t is 2.5. Okay. And it's a level terrain. So no gradient. So how much is my sight distance? Tell me.
Speed?
70. 70.
Time?
2.5.
I thought no. 2.5 seconds. Not given, we assume 2.5 always. Perception reaction time.
7 to 6.6. So on this road, I need a distance of 7 to 6.6 to be visible. Okay, to maintain this distance, I need to calculate this m or this m. Okay, depending upon what I have. They did not give me the radius, they gave me the degree of the curve, 6 degrees. So I will use this equation. Okay, so d is 6. How much is m? D is 6.
دي distance
D is degree of the curve. D is degree of the curve. ds is the distance. ds.
degree of curve 6 degree of curve.
Degree of curve 6. Capital D. Huh? 30.6? Yes, Muhammad.
Just checking.
Huh? 982? Oh.
I wouldn't know. 5729.58 على 6 واحد ناقص كوزين دي. كلهم داخل كسر؟ ايه كلهم. يا دقيقة مثل كله مثل كله. واحد ناقص كوزين كم باللي في الكوزين؟
726.6 into 6.
في 6 ضرب 6 لا على 10 200 بس سافر يطلع مور لارجر.
What are you going to do?
صح لا شيء لا 1892 good number actually.
Okay.
Maybe the DS. That's DS.
DS is fine.
Logic.
What logic? The curve is about 726. Your object is going 1900. Yes. How much was it for you? 30.6. Can I see?
صح لا
30.6 makes more sense. It's different than the other thing.
much close 30.6 doctor.
Yes, so 30.6 feet, 10 meters.
10 meters.
Yeah.
Ours is 300 meters maybe.
Yeah.
Or 600.
Anyways, you can check it later on, but it should not be that much. Okay. Okay, any questions with the logic? Okay. So, if you want to maintain a distance of this much, your object should be this far from the inside of the road.
Doctor,
Yes.
in the equation, the cosine is in the denominator, yeah?
The cosine is the 1 minus this only.
Yeah, the denominator, not in the numerator.
No, yes. This ratio is separate. This whole ratio into this whole bracket.
Okay, so
This whole ratio is.
so it's in the numerator?
Yeah. Okay, anyways. Moving on. We have the two other price of the curve, which are different variations of circular curve. One is called a compound curve. In compound curve, you have more than one curve joined to each other. Okay, and each curve has its own radius. We call it a compound curve. And why do we provide compound curve? To save space. So whenever we design highway ramps, so ramps take a lot of space and they have a lot of cost as well because you have to make them elevated. So to save the space and the material, we make compound curves for the ramps. Even in the parking spaces, you know the parking spaces which go from one floor to the other. We have to make them ramps. So those ramps are also compound curves because they save space. Okay, when you may have two curves which are not directly connected to each other. There is some space between them. But if this space is less than 200 feet, we will consider all of it as a compound curve. Okay, so compound curve can be directly joined, or it may have a space of less than 200 feet between them. In both cases, compound. Okay. Another thing you have to keep in mind is the change in radius from one curve to the other. This change in radius should not be more than 1.5 times. Okay. So you have R1, you have R2. R1 upon R2 should not be more than 1.5 times. Okay. If somebody did not give you the radius, they give you degree of the curve, then the difference between D1 and D2 should not be more than 5. Okay. If you have radius, you will take the ratio. Check the ratio. If you have degree of the curve, you will check the difference. The difference should not be more than this. Clear? These values are applicable to highway compound curves. If you are doing it in the parking lot, then they have other standards. In that case, it can be more than this ratio or this difference. Okay. The last one is a reverse curve. Reverse curve again, two circular curves. Okay, and they have the same radius but different directions. This radius and this radius same, but direction is different. In this case, between the two curves, we intentionally keep a straight distance of 200 feet or less. We don't directly join them together. Okay, they are not directly joined together. We always keep some difference between them. Okay, why? Because of the safety reasons. You can see it's very difficult. Steep, yes. Okay, you are going from one direction to the other. So in order to make it comfortable for the driver, we keep this much distance between the two curves. Okay, still we consider it as one reverse curve. Where do we provide it? We provide it where we need a change in path. So you are on the main road, or you want to go on the side road. Or you are on the main road, you want to enter the parking. Okay, so in these cases, you will see the reverse curves. Okay, clear? Any questions? Okay, thank you.